Hello and welcome. In this video we want to see how we can use Riemann sum for estimating the area under the graph of functions. In this particular example we want to use Riemann sum to estimate the area under the graph of sine of x from 0 to pi over 2. And we want to use 4 rectangles. In the first part of the question, we want to use 4 rectangles using the right endpoints. And then we use 4 rectangles, but we use the left endpoints. To estimate the area on the graph of functions, we don't need to know the graph of the functions. So basically, if you don't remember the graph of sine of x, still you can use the Riemann sum formula and you can estimate the area under the graph. But when we look at the graph of the function, then the calculation that we do in the Riemann sum makes more sense. So here, first I will show you the graph of sine of x. But it's important for you to notice that you really do not need to know the graph of the function. Here we want to estimate the area under sine of x. If you remember, the graph of sine of x is something like this. And it continues. Here is 0, here is pi, and here is pi over 2. We want to estimate area under graph of y equals sine of x from 0 to pi over 2. So basically we want to estimate this area here. So basically we want to divide 0 to pi over 2 to 4 sub-rectangles. So we have to choose 3 points in this interval with same distance. And then we have to make our rectangles. Before I show you how we make the rectangles, let me write down the formula for rectangles for the right endpoints. Riemann sum, when we have 4 rectangles, we show it with R4, R sub 4, because we want to use right endpoints, so we use R. The 4 shows that we want to estimate the area with only 4 rectangles. The formula is this: delta x times by f of x1 plus f of x2 plus f of x3 plus f of x4, which in this formula delta x is b minus a over n. N is the number of rectangles. Here we have 4 rectangles, so n is 4. So we have 4 in the denominator. What is a and b in this formula? A and b is the interval, is the beginning and the end point of the interval. So a is 0 in this question and b is pi over 2. So b minus a basically shows the length of the interval. So basically we have pi over 2 minus 0. Pi over 2 minus 0 is just pi over 2. Pi over 2 divided by 4 is pi over 8. So far we know what is delta x. Delta x is basically the length of each of these rectangles that we will make it in a moment. So we want to make rectangles like this here. The length or the width of these rectangles, whatever you want to name it, is pi over 8. But in this formula, what is f of x1, what is f of x2, what is f of x3, and what is f of x4? These are the length of the rectangle. So if we suppose delta x shows the width of our rectangles, for each of our rectangles we have to have the length of the rectangle. F of x1, f of x2, f of x3, and f of x4, they show the length of the rectangles. But what is x1, x2, and x3, and x4? x1 is here in this example, x2 is here, x3 is here, and finally x4 is the last point of the interval, the end of the interval. But what is x1, x2, and x3? And what is the formula? What is the general formula? I told you, you don't need to look at the graph. You don't need to draw anything for yourself. Just use the formula and simply you can estimate the area. So, if we ignore this graph, what is xi in general? Xi, which I can be 1, 2, 3, any number, any positive number, and also 0, is a plus I times by delta x. A, we know that a is basically 0 in this question. So, for calculating xi, we know the value of a. Also, we know that delta x is pi over 8. So, now that we have everything, let's calculate x1, x2, x3, and x4. x1 would be a, which is 0, plus, because we want to find x1, so I is 1, times by delta x. Delta x is pi over 8. So x1 is pi over 8, which, if we want to look at the graph, where is pi over 8? Pi over 8 is here. x2 would be again a, which is 0, plus 2 times pi over 8, which is 2 pi over 8 or pi over 4. But I prefer to keep it as 2 pi over 8. What is x3? x3 is 0 plus 3 times pi over 8. So it is 3 pi over 8. As you can see in this question, we have a pattern. Pi over 8, 2 pi over 8, 3 pi over 8. So basically x4 is 0 plus 4 times pi over 8, which is 4 pi over 8. And attention, 4 pi over 8 can be written also as pi over 2, which, as I mentioned before, it shows the right endpoint of the interval. So this is x4. Now that we have everything ready, we can use the Riemann sum formula for estimating the area under the curve. And so R4 equals delta x, which is pi over 8, times f of x1. Attention, the given function in this question is sine of x. And we have to plug in each of these x's that we have here, pi over 8, 3 pi over 8, 2 pi over 8, 4 pi over 8, all of these numbers in sine of x. So f of x1 is sine of pi over 8. The next one is sine of 2 pi over 8. Sine of 3 pi over 8. And finally sine of 4 pi over 8 or pi over 2. Now, if you use a calculator to estimate the expression inside the bracket multiplied by pi over 8, the answer from your calculator should be 1.184. I rounded it to 3 decimal. So as you can see, even without looking at the graph of sine of x, you can estimate the area under graph of sine of x from 0 to pi over 2 using Riemann sum. But before I show you how we can do this for the left endpoints, let me draw the rectangles that actually we calculated the area of those rectangles for the estimating of the area. The first rectangle is basically this rectangle. Attention, the first point was x1. x1 is here. So from here, we went up to the curve. When we cross the curve, we make a rectangle. This is the first area we calculated. The area of that rectangle is basically pi over 8 times by sine of pi over 8. The width is pi over 8. The length is sine of pi over 8. Can you find the next rectangle? The next rectangle is from here to here. We go up, we cross the curve. When we get to the curve, we make a rectangle. The area of this rectangle is pi over 8 times by sine of 2 pi over 8. And so on. This is the next rectangle, and finally the last rectangle is this. So by adding the areas of all of these rectangles, we got this value. Before I show you the estimating of the area with the left endpoints, I have a question. Do you think this answer is overestimate for the area, the actual area, or underestimate? Yes, it is overestimate, because when we look at the rectangles, we can see that all of these rectangles lie above the graph of sine of x. Attention, graph of sine of x is this. And as you can see, these rectangles are above graph of sine of x. In general, when we have increasing function in the interval, of course, in the interval that we want to calculate the area, the right endpoints, when we use the right endpoints, we get overestimate. So attention, sine of x in the region, in the interval from 0 to pi over 2 is an increasing function. And whenever we have increasing function, the estimate that we get from using the right endpoints is overestimate. And the estimate that we get from the left endpoints is underestimate. For the left endpoints, the formula with 4 rectangles is this: delta x times by f of x0 plus f of x1 plus f of x2 plus f of x3. For a moment, let's compare the two formulas, the right endpoints and the left endpoints. If you compare this formula here with this formula, delta x is delta x. The difference is here. When we use the right endpoints, we start from x1 and we continue up to x4. So when n is 4, we start from 1 to 4. But for the left endpoints, we start from 0. Always we start from 0 with the left endpoint, and we continue up to n, which in this question is 4 minus 1, which is 3. So the difference, the only difference between right endpoint and left endpoints are the first point and the last point. When you use right endpoints, you start from x1 to x4. When you use left endpoints, you start from x0 up to x3. Now let's do the calculation for the left endpoints. Delta x is again pi over 8, because we know that delta x is b minus a over n, which in this question n is 4, so it's pi over 2 minus 0 over 4, which is pi over 8. Of course, you don't need to calculate delta x again. Do you remember the formula for xi? Xi is a plus I delta x. And in this question, a is 0, so we have 0, x0 is 0 plus I, because we want to find x0, so 0 times delta x, pi over 8. 0 times pi over 8 is 0 plus 0 is 0. Basically, the x0 in this question is exactly here, the left endpoint of the interval. We don't need to recalculate x1 and x2 and x3 because we did it in the previous part. If you remember, x1 is pi over 8, x2 is 2 pi over 8, and x3 is 3 pi over 8. And so L4 would be pi over 8 times f of 0 plus f of pi over 8 plus f of 2 pi over 8 plus f of 3 pi over 8. So L4 equals pi over 8 times f of 0. If you plug in 0 in the given function, which is sine of x, it's sine of 0, and sine of 0 is 0. So basically we have sine of 0 plus sine of pi over 8 plus sine of 2 pi over 8. For sine of pi over 8, you need a calculator. Of course, you can write 2 pi over 8 as pi over 4, but we use a calculator for finding these values. If you add up these and you multiply by pi over 8 with a calculator, you are going to get approximately this number, 0.791. And as I said before, this is underestimate for the area. Let me show you when we use the left endpoints. Actually, we are calculating area of each rectangles. Here is pi over 2. We make 4 rectangles, 1, 2, 3, and 4 is here. Because for each of these width that we have here for the rectangles, we want to use the left endpoint, so we use this point for the first rectangle. And because we use this point, at this point the value of the function is 0. And so basically we are not going to make any rectangles. It's a rectangle with the width of this size, and the length of the rectangle is basically 0. Attention, this is the width of your rectangle, and this is its length. What is sine of 0? 0. So basically, actually, we don't have any rectangle. It's a rectangle with length 0, so it's just a line. The next rectangle is a rectangle that its width. Let me use another color to show it better. The next rectangle is a rectangle with same width, but not the length is sine of pi over 8. Sine of pi over 8 is basically this. So we calculate this area. Then the next rectangle would be this. Attention, always I am using the left endpoint. We go up and then we make a rectangle. And the last rectangle here is this. We use this point, we go up, make our rectangle, and this is the last rectangle. So basically by adding the area of these rectangles, we get this value. But what is the actual area of graph of sine of x from 0 to pi over 2? The actual area for sine of x from 0 to pi over 2, this is the exact value of the area, is 1, which later when we use integral formulas, we can find the exact value. But here just we want to estimate. I hope by watching this video you have learned how to use the Riemann sum for estimating the area under the graph of functions. If you like videos like this, please subscribe in my channel. See you in the next videos.